Welcome everyone. Today I'm going to talk to you about our work on automatic replacement of low-level function in Ethereum smart contract. My name is Ray Xi and I'm from the University of British Columbia. Now I'm going to start with a more general question on programming language. So do you know how evil a function can be? I still remember there is a function which is called eval in JavaScript. Similar evil functions exist in many other programming languages, like Python, they also have eval. Java, they have reflected call, and C, maybe there are some insecure call. These evil functions may introduce weird bugs into your project, and sometimes it may break your project. Similar things happens on Solidity and smart contract programming language, but this time these eval functions bring greater financial loss. For example, 42 ethers, which is about 100,000 US dollars today, are lost due to a evil function in Solidity, which relied on return value check to proceed. To prevent these incidents from happening again, the community has developed many guidelines to alert developers not to use these bad practices. Simultaneously, many research work on vulnerability detection in Solidity also show that there is a tight binding between the vulnerability and the bad practices. So I was thinking, if we can automatically enforce the community guideline, can we really eliminate the vulnerability from its root? The answer is yes. So our ultimate goal in this work is to enforce the guidelines. But here comes another question. There are so many guidelines, and which guideline shall we choose? We choose to start with the Solidity official documentation. We collect all the warnings listed in the doc and select them based on three criteria. First, there should be no mature solution for this warning. See if there is a simple library that can simply address one warning. We can just import it and use it directly. There is no bother inventing wheels again. The second criteria is the warning should have a real-world exploit. Otherwise, it's no worth to patch them, right? And the third criteria, we focus only on syntax level warning. And at this work, we don't proceed to the semantic levels warning. Based on these three criteria, eventually we find that there are 11 warnings out of all 21 meets that criteria. All the 11 comes from three main categories of functions, which are deprecated send, low-level call, and inline assembly. And so we came up with our own term, low-level function, to describe these categories of functions. After we define the term, the next question is to answer how widely it is used in the production area. We carry on an empirical study on two real-world datasets. The first, it is called the base dataset, spanning from 2016 to 2019. It includes all open source contracts available on Etherscan. We observed that 3/4 of the low-level functions used are actually unnecessary and replaceable. For comparison, we also include a more recent dataset in which the contracts are deployed after the guideline is published. We found an increasing chain of the low-level function use. It doubles, almost triples the percentage in the base dataset. Now we can draw a conclusion that the developers seems not to follow the guideline even after the guidelines are written in the documentation. Well, guideline is good, low-level functions are bad, and the documentation also tells us how to replace it. And so we can do the replacement. However, this is not a trivial task. In the documentation, the authors provide a direct replacement to replace deprecated send into a better function, which is called transfer, as shown in the example. However, in the reality, developers tend to use different encapsulation to wrap the low-level functions. For example, you can see they use if clause, require statement, and return statement to encapsulate deprecated send. And there is no one silver bullet for all the patterns. So we should develop different patterns for different encapsulations. In total, we distilled 11 patterns from the base dataset, capturing all the low-level function cases in the datasets. These 11 patterns compose our GoHi's pattern database. To fully replace a contract with low-level function, we first compile the original contract into its AST representation. GoHi matches and replaces the subtree according to the pattern database. After the AST is successfully replaced, GoHi recompiles the AST back to its source code form. This wraps the whole process of a source-to-source replacing process of GoHi. We also do some experiment to evaluate the performance of GoHi. In this part, we answer three main research questions through the experiment results. The first question is coverage. We write a regular expressions to capture if GoHi meets any cases. The results show that we eliminate all the in-scope low-level functions. So we can claim that GoHi reaches a 100% coverage in the dataset. The second question is the syntax correctness. We check the compilation output of the replaced contract and compare with the output of the original ones. We find that all of the replaced contract pass compilation and over 96% of the replaced contract get less warning or same number of the warning compared with the original ones. The third question is about consistency. We check if the replaced version is identical to the original by replaying the transaction. We compare the contract states after the replay and find that all replaced contracts are identical to their origin. So I wrap up today's talk with some takeaway. The first takeaway is the majority use of low-level functions are actually unnecessary and replaceable. By enforcing the guideline, we can eliminate them from their roots. Second, we observe that developers seem not to follow the guideline even after it has published. And third takeaway, our tool works well on both base dataset and recent datasets. And that's all of my today's talk. Thanks for watching. You're welcome to read the paper and reach me via my email.